Hello everyone. So in this lecture we're going to start data structures. So far we have seen how to analyze time complexity if you are given an algorithm or if you are given a code snippet, how to analyze the complexity of that. So as in the first class I discussed what is a data structure. So just to give a brief overview again, it is a way to organize data, way to organize data, and it provides us the operations on how to manipulate data. Okay. So what's the meaning of this? Why do we need the organization in data? Okay, and how what manipulation will it provide? So these are the things that we are interested in data structures, because if you are in certain scenarios, so one data set will make sense. So that's why we have to learn about many different types of data structures, so that if there is a particular problem, we'll be able to know which data structure that is best to use. Okay, the first data structure that we are going to start is arrays. Before arrays, I would like to give you an overview of ADTs, what is called as abstract data types. Abstract data types. They are sometimes also called as interfaces. Okay, there's a difference between data structure and abstract data types. So what is the difference? The difference is that one provides you the specification. So I'll just write the differences like this. So let's suppose this is our ADT on the left hand side, and then we have data structures on the right hand side. Okay, so what I'm saying is the collection of supported operations, this is called as ADT or interface. So as I said that first we'll store the data. Let's suppose now you'll store the data in memory in somehow. As an array, you will store it in the continuous fashion. In the stack, you will store it in a different fashion. So the first thing is what will specify you, because if I tell you what interface and address structure, what the difference between that, it is like you have a map. Okay, if you want to construct a building, for that you'll first have a rough sketch of that, and after that you will implement that thing. The rough sketch we can call it an interface. Okay, then the actual implementation we can call it a data structure. That is what it means. The first thing I said about interfaces is that it provides a collected collection of supported operations. So it gives you collection of supported operations. This is like providing the specification. Okay, because when you are building something, you must specify what are the things that you need in it. So that is the reason we first want to build an interface. After that, from that we'll create a data structure. Even when you are in a real world scenario, before doing anything, you first plan the thing and you sketch out it, then it comes up in the practical reality. So first the thing is an idea, and with that idea you have to check, okay, what are the things that I want with this. So that's what interface means, or abstract data types means. It's a collection of supported operations, or what are the operations that I want to suppose. Oh, it's this interface basically is specification. You can also call it as specification. It says what are the features, what are the things that are in there. So if you are building a car, before that you'll first create the different modules of car, and will see, okay, my car should have this, the car should have this. You'll create a specification of the car. That is what this interface gives. Okay, and then what data structure is? It is an actual implementation. It tells you a way to store data, so it gives you a way to store data. So what is the way that you can store data, and which algorithms to support, and what operations does it support? So here you are seeing the support operations. Here you will implement the operations. Okay, and then here you will actually basically have the have the implementations. Okay, and data structure is basically a representation. So it represents the thing. So if you talk about the actual car, and now you have a physical thing in there. So that is where this data structure comes in. So is the difference between interface and data structure is clear, or ADTs they are sometimes called as abstract data types? Is it clear?
Yes, sir.
So now we have different abstract data types. The first abstract data type among them is a list. So what is a list? So it will basically specify some properties. It will specify some properties. Okay, this is what I want, and after that, this is what I want, and then we'll have an actual realization of this list, which is called an array. So list is an abstract data type. So this is again an ADT as a interface. So in real world scenarios, what it is like a blueprint, like a map, because you have to draw something or you have to make a building. Before that, you will make a sketch of building. Okay, what does the building look like? How many rooms will it have? Where will be the kitchen? Where should be the dining hall and something like that. So you first will specify the things. That's why list, it is nothing but an abstract data type, a sketch. And what are the characters? Now we'll see what are the characters of list. Okay, there are different characters that we want in the list. The first thing that we want is, let's suppose we want to store something in the continuous manner. Okay, so let's suppose this is one of the specification. Then we want, when we search for an index, so it should be indexed. Let's suppose it should be indexed. I'm just giving you rough things, and then we'll see how the array fits into this. Okay, after that we want to have uh, get operation, or get in, like, for example, get element, and we want to again have an operation set element. People are messaging. I'll just close this. Give me a second. Yes. So over here we are saying that it should support certain operations. So what are the operations that it support? First, I'm saying that this is the property it should have. Let's suppose we will store it in a continuous fashion. Then it should be indexed. By indexed, I mean you can just point at an index and get the element at that point, or set the element. So we'll have get element, we'll have set element. Okay. After that, we'll have a concept of head and tail. We'll have concept of, okay, where is the first element, where is the last element. We'll have concept of head, concept of tail. Head means the first element, tail means the last element. And similarly, we can have the functionality. Okay, what's the length of this? What's the length? Length means how much bigger it is. And then we can also have a concept of, is it empty or not? So is there no element at all? Something empty is empty, I'll see. So what I gave you, it is a specification now. So this whole thing is a specification. This is a blueprint. It is the, because you want to construct a building. For a building, you must have the drawing is a sketch. Okay, why should be the bedroom? Where should be the washroom? And how much area should we have for the flat, or something like. When you're constructing, you will first create that sketch. You will first create that blueprint. So before creating a data structure, you know what are the things that it should have. So that's what I'm saying. This list is an abstract data type. So abstract data type gives us the interface, it gives us the specifications and tells us supported operations. These are the specifications. The specification is it should be allocated continuous memory. Okay, one after other adjacent memory, and then it should be indexed. You can just use one index to get the element out of it. And similarly, you can set the element also. You can have a concept of head or tail. Okay, head means the first element, tail means the last element. You can get the length of, what's the length of that list. Okay, you can also check if it is empty or not. Okay, all these things are the specifications uh, that I gave you. Now we need to realize the rest. We need to bring it in the actual implementation. The first implementation that we'll see is an array. So array basically is an implementation of list. So how many of you are clear now? So because you are using this list in Python, I don't want you to confuse this list with Python. So I'm saying list, they have named it something. So when the builders, the language wanted to build something, they had to name it. Okay, but what actually the list is, it is just giving us the set of operations and the specifications, and now we have to implement it somehow. So the implementation of list, one of the implementations, array. Okay, so the first implementation is array. This is the first implementation of the list. So list is our blueprint. This is our map, or this is our sketch. From this, we want to implement it in the real world, and we want to see. So the first implementation I'm telling you is array. What is an array now? So array, it should have the continuous memory. That's the first property that I wanted from it. The first property is that it should be stored in the continuous memory locations. That is what array is. So now second thing is, it's a collection of homogeneous objects or homogeneous data types. Okay, like I'll write what are the properties of this, because now ADT, it specified the operations and it specified the specifications for it. Now I am going to the arrays and to see how to basically realize this, how to get into the reality. The first thing the arrays are, so they are the collection of items, okay, of same data type. So collection of items of same data type. So now you know what data type is. So it's the type of data that we'll be using. Let me give you a physical example. Let's suppose you have a bus or a car, a bus or a car. Okay. So in bus or a car, you specifically say, for example, this bus is only for humans to ride. Okay. You don't allow pet animals, or you don't allow something like that in that. So here you'll see everything homogeneous is there. But then we have these trucks. So in these cargo trucks, the only things that are allowed are the items, okay, which you have to transport. Similar thing in that is, so if you have a collection of items, and why do you want to have same data types? So why do you want to have this? Let's suppose you are storing, you are making a database on students. So here you are storing the marks. Marks basically will be in, it will be a numeric type. So there you will store it as floating point numbers. Like for somebody got 30 marks, somebody got 31 and a half marks, something like that. So if you want to store those collection of data, those same type of data, so there you will use arrays. So why was this array even? Why was it conceptualized? Because the thing is, let's suppose if you have to store marks of many people, the first thing is you'll have to create a lot of variables. The first problem we had is, if you have to store something, so the point was that if I have to store, let's suppose, marks of Amir, so I'll write marks, then I'll create a variable. Let's suppose I'll call it marks, then I'll name it as Amir. So I'll say Amir got, let's suppose, 30 marks. So this is one variable. Then I'll have to store, let's suppose, marks for Zakir. So I'll write marks Zakir, that's equal, let's suppose, 35, something like this. So if I have to store, let's suppose, for 50 students, so I'll have to create 50 variables like this. Now I know that the data type is similar. You see over here, the type of data that I'm storing is similar. So is there a way? Is there a way so that I can store the data in a fashion so that I don't need to separately name them? That's where the concept of arrays came in. That's why I said it stores the same data types. Okay, this is where the need of array was there. That's why we first described it, the abstract data type of an array. So it should be a list which should be given the continuous memory location. That's why we'll now construct it. So what we did is, so as programmers, so we said something. Okay, let's because I have showed you that RAM word model. So let's suppose this is our memory, this is our RAM. Now what will I do? I'll take a chunk of memory. For example, I'll take this much of memory. Now now it can store, let's suppose, three elements. So I'll now call this, let's suppose, marks array. I'll suppose call it marks. Now you saw that I have given the continuous memory. The first element is this, second element will be stored here, the third element will be stored here. So the elements are stored one after other in the memory. So they are stored in a contiguous fashion. Okay, memory locations are contiguous. That's the first thing. The first thing that I said is it should have same data types. This is the first thing. The second thing is, now the memory allocation is contiguous. Okay, that's what I'm saying. When you had some problem and you had to solve this as a software developer or as a computer scientist, you'll have to solve the problem. The problem that you faced was that if you have to assign similar data to multiple variables, you thought, why to just create, why to keep on creating variables? It is better I'll create an array of variables. That's why it's called array. Array literally means one thing after the other. So there's an adjacency, the concept of adjacent things there. So in the computer's memory, what will happen is, so it will store something like this. It'll take a chunk of memory that is stored in the continuous fashion. So first element will be stored over here, second element will be over here, third element will be over here. So that's the second property of the arrays. So array, the first property is it is storing the, or it is a collection of the items which have same data type. So second is that when you do the memory allocation, it is continuous. So that time you will get contiguous memory allocation. Then after that, the third property that arrays have is they have usually the fixed size, because you have to tell upfront what is the size. Fixed size. Okay, so and they are used like that. For example, I know that I have to store marks of 30 students. So what I do is I'll create an array for 30 students in which there are 30 memory locations where I can store 30 things. So that's what we'll have to in many of the programming language. Now you'll have to even define, for example, if you see C++ or Python, Java, so then they will have their own implementation of arrays. and they'll differ by a bit, but more or less they'll be similar, they'll be following this thing. Okay, because let's think about from the perspective of a compiler designer or a language creator. So how will he think? Because first thing is, he'll have to give you some access to create some primitive data types like integer, float, string, and something like that. After that, programming language also should have arrays. Okay, if you see C or C++, so in that we don't have a data structure directly arrays. So there we'll create a run of, let's suppose, characters or things like that. So you'll define something as integer character of this much. Okay, so the language designers, they decided, okay, this is how we'll implement the arrays. In Python, you won't see this homogeneous thing. Okay, because I'm saying the collection of similar items. So but there we have list can store different types of data. So that is the design choice, the Python designers, how they designed it. But this is what array is. Array, it should have the same data type, the memory allocation should be continuous, it should be a fixed size. Okay, and after that, if you what it should have is, again, I should be able to get its length. That's the specification I had. Now the one other person will implement this array within the programming language. How many of you are clear with the concepts we read so far? I cannot see the screen. Please have somebody
Yes, sir.
reply.
It's clear.
Okay.
Yes, sir, it's clear.
I don't want to give you the notion that we are per se just reading this stuff, the array. Okay, I want to declare this. Like, I just want to give the notion. Okay, just think about this, that you are a computer scientist, you are a designer of a language. The first thing that you should know is, okay, these are things that I want to implement. Then it is upon the designer, how does he want to implement. The C++ arrays could be different, and Python list, how they decided to implement could be different, because every language, the design philosophy. Okay, every language, the design philosophy. C's design philosophy was to be faster. No matter what you do, the philosophy of C was it should be faster. Okay, and the design philosophy of Python was ease of programming. It should be easy to code. That's why if you see, there are different things in Python, like really really easy to code, because even it has removed data types, it has removed many other things that other languages had, because the design philosophy it had, it was and it was created by a mathematician, and you will see frequently the symbols of mathematics being used over there. Okay, so whenever you have some language, they'll differ here and there by a bit. Why? Because it is a design philosophy which describes the language, and it's up to the creators of the language what they decide to do with it. Okay, that is the thing. If these are the arrays, and now you can have different implement. If you see C or C++, you will have the same data types. You'll have continuous, you'll have fixed size. But in the Python, if you see, there we use list as an array, and list does not follow many of these properties. List is not fixed, it's a dynamic thing. And then the allocation, even you'll have to say if it's continuous or not. It all depends on the implementation, how the designers chose to implement it. Okay, now we'll see some more concepts of the arrays. So the basic terminology that I'll be using in the arrays, the first thing is index. So what is an index now? Because I said it should be indexed. So if you see the ADT, because ADT is a list, and then its realization is, the first realization of list is array. So array would look something like this. You should have this mental image. This is a mental image. There's nothing but mental image, but they won't look in the computer's memory like this. Computer's memory, if you see the RAM stick, okay, there you have what are called as flip flops, where you have these, you store these bits. Now you will have like something like this. Okay, there will be compartments. Compartment basically means there is this where they can store the elements, where they can store something. Now you will have the access of the first element. Okay, you'll have the address access of first element. Just think about the RAM, because in RAM it's a run of memory, there will be memory cells, and now you are addressing the memory. If you have 64-bit machine, so that means your word size is 64-bit. That is, you are giving one address to the 64 bits. It means, let's suppose if you have RAM like this. Okay, let's suppose each of this line is 64 bits, so these are 64 bits. Okay, this is 64-bit, so you'll have one address for this. Okay, let's suppose this address will be starting from 10. This will be an address. Then we'll have 64 bits more. Then we'll have address of 11 over here. 64 bits again. Okay, then we'll have its address as 12. Its address will be 12. Have this picture in like, this is our RAM. That's what this is our RAM. So RAM is basically made up of flip flops. Flip flop basically means it stores a bit on or off. 1 is 0. It stores like that. Now you cannot address each bit. If you address each bit, you won't be able to store much. So what are you doing is, if you have a 64-bit machine, that means you are combining 64 bits and giving them one address. Okay, and this is the address of those 64 bits, and the second address is this 11, and it depends. And usually this is the concept that you will study in operating systems, and how do you do this memory management stuff. But I just want you to have this higher level picture, that we have a RAM. A RAM basically is just a bunch of bits, a bunch of flip-flops, and now you will have to address the RAM. So how is the RAM address? So bunch of bits, 64 bits, or if you have 32-bit machine, 32 bits, they're clubbed together and they are given one address. This is what I have showed in the picture. I hope this picture is clear now. So after that, now you know that there are some things which will take more than 64 bits. Okay, they'll take more than 64 bits. Let's suppose you are defining something. So it depends on the compiler. So when you design the compiler, that time you'll have to decide, okay, integer should be of this length. So my integer has the range from this to this. My other variable, let's suppose float, should have range from this to this. So it takes these many bits. So based on that, we'll define an array. Okay, if this array is of integers, so let's suppose each element, let's suppose, takes some number of bits, 8 bits or something like that. So that's how the memory will be stored after that. So what I'm saying is, this array will be given the address of first element. So address of first element, that's what will be given. From that address we can compute the second element, third element, fourth, fifth, like that. Okay, and usually these are I was talking to you about what is an index. So index basically is, so when you want to access the element now, so you are saying it starts from 0, 1, 2, 3, 4, 5, 6, 7, and 8. Let's suppose this is called an array. So I'll name it as ARR. So this is our array. So what array gives us? It gives us the basically the location of the first address. So it gives us, let's suppose this address is 10. So this now will be 11, 12, 13, 14, 15, 16, 17, 18. That's what I said. I said array that it is stored in the continuous memory location. I'll just erase this memory model. So what array gives us? It gives as the address of first location. Now if you go to this fourth index directly, so what will happen internally? It will perform some calculations. It say, if you do you want fourth element, so it means, because I have array and I have it is location of the first, I have this 10. Okay, 10. Now you are indexing 4. It will directly add to the base address. This is called as base address. To the base address, it will just add this 4, whatever index you gave. So it will reach 14. So this is the address it will reach. So it will directly go. That's why they are 0 indexed. Why? Because it makes calculation easy. So if you see, for example, if I did not have this 0 indexing, so this address would have been, let's suppose, 10, 11, 12, 13, 14. So now if I want fourth index thing, so I have base address of 10. So I have base address of 10, then 10 plus, then I will have to add, let's suppose, my index is 4, then I will have to minus 1. Okay, if it was, let's suppose I was incrementing this, let's suppose I was doing this. So let's say if array was not 0 indexed, not 0 indexed. So what will happen that time is, let's suppose now it's not 0, it's indexed from 1, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what should happen then? So because I told you we are given just the address of the base element, the first element. So we call it in base address. So when given in base address, so if you want to index it, if you want to go to the fifth, let's suppose this fifth index. So what is the address? It's 14. So now what you will do, base address is 10. Your index plus index is 5. Because we want to directly go to the fifth element. So it is 1, 2, 3, 4, and fifth element. So now if you see the address came out to be 15, you will have to perform minus 1. You'll have to reduce 1 from it to go at the 14. So you'll have to perform one extra calculation. Think from the perspective of, from a computer scientist who is implementing this thing. So for each indexing operation, initially you are performing addition. You are just saying base address plus whatever index you are asking for. Then I'll have to subtract 1. Now it requires 3 operations, at least like 3 arithmetic operations. First base plus index and then minus 1. So it is better to store it as 0 index. So if I store this array so that I start my index from 0. So I'll say 0, 1, 2, 3, 4, 5, 6, 7, and 8. So what will happen is, now I don't have to do this extra calculation. I just have to say base plus index. So now if you want to store, if you want to get the fifth element, so what you will do is you will say index of 4. So here you will directly get over it. So you say I want fifth element. Let's suppose you want fifth element. So in that you have this 10. Now the index is 4. So you'll directly say 10 plus 4. This is equal to 14. Is this clear? Why does the indexing start from 0? Because it saves us one operation. It saves us this negative because subtracting one from it. So that's the reason we start the indexing from 0. And there can be other reasons also. The best reason I can think of is that it starts from 0 indexing because it gives us when you access the memory and you want to just go to some indexed location, that time it doesn't have to perform this one additional operation. It just adds the index and it gets to the address. Are you clear with this?
Yes, sir.
So, so that's whole of the point of this course. I don't want you guys to just mug up the things and memorize everything and do not understand and learn the concepts. I want you guys to learn how to think basically. If you are a programmer, if you are a software developer, if you are a compiler designer, how to think like a compiler designer, and then how to design these things. Now you have this array. So I'm saying if you have to go to any index, so you just have the base address internally. What will happen is base address plus your index. It literally land you to that element. So let's suppose if you want to access this fifth element, that is you will just say I want to go at array of 4. What internally will happen is, so it will do base plus whatever index you asked for, so it will just give you that address. So and given that address, it will directly go to the memory location and fetch the element. That is the one terminology that I want you guys to know. Index. The second terminology is an array element. Obviously you know that. So anything that is stored in this array is now called as array element. So let's suppose we'll store 2 over here, or we'll store 5, 6, something like that. So these are called as array elements. So we have index, then we have array element. So anything that we store in the array is an array element. Then we have array length, because as I said that this is fixed length. This is called a static array. Static array is of fixed length. That is, you have to describe the length of the array upfront. That, for example, in C or C++, you have to describe it. If you say int array of 5, that will allocate memory location for 5 elements. But Python is a little bit different. The reason being is a design choice. Design philosophy of the languages, ease of programming. We don't want to burden the programmers with, okay, define the size. So it made it again abstract. But if you ask me about what an array is, array basically is of fixed length. So array length means what is the length of array? It's how many number of elements, basically number of elements that we can have in an array. So these are the things that terminologies that I'll be using, and I now will assume that you know what an index is, what an array element is, and what are these things. So I'll not just go through them again and again. So this is what I want you guys to remember. Now we have different types of arrays. Okay, we have different types of arrays. This is again a memory construct. Actually, there is no types of arrays. Let me tell you frankly, there is no type of arrays. This will come like a shock to most of you. Like the sir is saying that there is no types of array. There is only one type of array. One type of array means there is one D array only. But how we think as a programmers, when somebody codes, he'll have to make a mental model of that. So for that, we give him different types of arrays so that it's for the ease of coding. Otherwise, you know that RAM basically is a run of memory. So RAM is like the run of memory. So RAM's address will, let's suppose, start from 0x something like this, 0x, let's suppose 15, and it will end at 0x, let's suppose 1500. This is just a run of memory. So there is no concept of 2D, 3D, 4D arrays, nothing like that within the memory. But these are just the constructs that will make your understanding easy. But when you code, if you have these sort of pictures and mental pictures in your head, it will make your code easy. That's why even when designing the language, they said, okay, these are the types of arrays we had. But internally, everything is stored in the similar fashion, because computers memory or computer, they don't discriminate between 1D 2D array. So they're just the constructs of our mind. So I said this is the memory is just a run of flip-flops, a run of bits. So we have this 1D array. So 1D array means, so you will have a picture like this. You'll have a picture like this. 0, it will start from, the index will start from 0, 1, 2, 3, 4, 5, 6, 7, something like this. Okay, this is our 1D array. And the 1D array just is like a row of elements. You can think around this. And then we have 2D arrays. So 2D array, it can be thought of a matrix. Again, if you see, go into the computer's memory, there is no 2D array, nothing like that. So what this 2D array is, this 2D array gives the programmers flexibility. Okay, now if I want to define something which is 2D, so I can define it like this. So let's suppose if I have to define something as a matrix. So natural way to define a matrix is in a 2D array. So you will say 1, 2, 3, 4, something like this. Now many of you might have heard that how is this stored in the memory. So this is stored in two types. This is stored in column major order or row major order. So what is this column major order? So now you know that computer is just a run of memory. So I'll make a RAM over here. Let's suppose this is our RAM stick. Okay. So RAM stick will be just a run of bits. Now you have to store this 2D matrix. You have to store it somewhere. So how will you store it? So you will take the first row. Okay, you will take this row and you will store it here. You'll store the first row. Let's suppose over here. Then if you store the second row like this, if you will take the second, this was first row and this was second. Now you will place the second row over here. This is called as row major order because you are storing one row after the other. Okay, the first row, then the second row, then the third row, fourth row, like this. You're taking this row, storing it over here. You're taking this row, storing it over here. And if you're taking now this row, storing it over here, because the memory is just a run of bits. There is no difference between 2D, 3D. So what is the column major order now? Column major order is the reverse of this. So it is storing column, it is storing it column wise. It's storing this column first, then it's storing this column, then it's storing this column, it is storing this column. So why are they different? Because I said when you define an array, the array just gives you the base address. It gives you the address of the first element. So now knowing that if you are storing array in a column major order or row major order, you'll have to perform different calculations. Let's suppose if you want to go to this element. So for to calculate its address, you must know is the array stored in row major or the column major order. So if it is stored in row major, you will say first address will be given to this, second, third, fourth, then fifth and sixth address will be given to this. So you will say 10 plus some, let's suppose some whatever the index you gave, and you'll perform the calculation accordingly. But now if you are storing it in a column major order, so what will you do? So in row major order, it was the sixth element. So in the column major order, it is 1, 2, 3, 4. It again sixth, fortunately. So because this is even matrix 4 cross 4. Sometimes if you have rectangular matrix, you will have column major order. It will have different address will be same, but you will access it differently. Okay, that's why we want to know this to how it is stored. If it is stored in the column major order, the calculation of address computation will be different, or the how do you access that element internally, computation will happen differently. Okay, based on if it is stored in column major or row major order. How many of you guys are clear with what is column major and what is row major order? You can ask questions over here. So from the memory perspective, there is no types of arrays because we'll have to store it somewhere to give a programmer ease to think and programmer to give natural ways in which he can implement things or in which he or she can implement things. We have constructed these things. The 1D array means you can just think it as a row. The 2D array you can think it as a matrix. Or there is another way you can in which you can think about these 2D arrays. You can think at arrays of arrays. Okay, now we are in 2D arrays. So the first thing that I said you is you can think them about like a matrix. You can say that we have a matrix like this, something like this, and there are rows. Now we learned about how they are stored in the memory. They are stored in the row major order, column major order. Why does it matter? Because it matters because internally compiler they have to perform calculations. When you ask for an index, let's suppose this is indexed like this 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. So when you ask for this element, let's suppose you ask for this element. This element is 4, 3. So when you ask for these two indices, it will have to perform calculations. So now if the compiler knows or if the programmer has initially told, okay, I want to store this things in a column major order, the calculations will be different. If it is in row major order, calculations will be different. So in the row major order, if you see, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24th element. So now if you see in the column major order, so this is 5, 5, 10, 15, 16, 17, 18, 19, 20. This is 20th element. So in the row major order, this was 24th element. So in the column major order, it was 20th element. So based on this, you'll have to perform calculations. So because you are just given the base address. That's what I'm saying. So I'm saying, so that's if the representation you think is like a matrix, so it is stored in a column major order or a row major order. Based on that, it will perform calculation differently to get you to this index. Then the second way to think about this 2D matrix is array of arrays. Array of arrays. So this is the first way to think. This is the second way to think. So now I'll just remove this matrix representation. I'll show you the array of array representation. So what is the meaning of array representation? So this means you have an array. You have an array like this. Array basically means row. Now in here each element is again an array. Okay. So if you see in the 2D array when you saw the matrix, so matrix was something like this. So this was our matrix. Okay. So now what I'm saying is I'm saying each of this element, each of these elements, they again contain an array within themselves. So it's like this. So now this is an array. Now this is an array. This again is an array. Something like that. So here now you can store elements. Okay. So this is called as array of arrays. So array of arrays means so there's a first level of arrays. Now these does not store elements. So what they store basically is they'll store another arrays. So this will now have address to this array. This will have address to this array, address to this array, and similar things like that. So when you want to store the element, if it's a 2D array, you'll store it here. Here you'll store 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, something like this. So you'll store in these leaf nodes. Let's suppose we'll call them leaf nodes. So the first level of array will have elements, and these elements itself will contain arrays. Okay, they'll have address to the array locations. That's how actually Java implements the arrays. Okay, this is how Java implements the arrays. It's stored in an array of arrays. You'll have to see the language specification to see how is the array stored. So that's why Java in Java you can allocate like this. You can say, for example, you can have array in which there are different types of array. Here you can have in the first you can have 5 elements. Let's suppose you have five number of these memory locations. In the second you can only have 4, something like this. Okay, then you can have only 3. That's why this array of array concept is a little bit different. And implementation wise, when the compiler design and when the language creators were designing it, they have to choose the design choice and accordingly have to perform calculations. Is it clear? This is our 1D
Yes,
array,
sir.
2D array. There is nothing like 1D, 2D arrays, but for the programming ease, when you are coding in a language, that time you will have to think
Yes, sir.
into a construct. Okay, for that purpose, you'll have to have a mental model of these things. That's why we have these 1D, 2D, and multi-dimension arrays. Let's call now 3D arrays. How to think about 3D arrays. So 3D arrays can be thought like a cube. For this is your first slice of the array. Then you'll have second slice like this, and you'll have third slice, fourth slice. There will be slices of arrays. So it will look like this. The array will look like this. So in this you'll have the first array. You'll have the second array. You'll have like this metric. You'll just have slice of bread like things. In that the first is 2D, then we have 3D. We have the second slice. We have the third slice, which makes it 3D. Or we can think in the array of arrays. The first will be array, which will again contain array, and this array also will contain array. There will be 3 levels now. Okay, so if you have 4D arrays, you will have 4 levels now. In here you will have this bread stacked on top of each other. This is what the concept of multi-dimension array will be. Like if you have 4D arrays, you'll have 4 levels. If you have 5D arrays, you'll have 5 levels. If you think about these levels, if you think about this bread, these cubes, so what you will have in 4D array, now you will have these stacked together. This is our 3D array. Now if you stack two 3D arrays together, if you stack another 3D array like this, okay, now it becomes a 4D array because we cannot imagine beyond 3D. That's why we stack these things up on top of each other. Okay, I hope that these things are at least clear. Like there are types of arrays which are just a programming construct. Programming construct means basically they don't exist in reality. Reality means memory does not differentiate between 1D, 2D. But to give the programmer ease, so there are different types of arrays so that when you have to code something, you'll think you'll have these mental models within you, and that time you'll know this. And what are the operations that it should support? Operations that are usual supports operation. All these were defined by the ADT. ADT means our abstract data type, which was our specification and types of operation. So here the first thing is we'll have traversal. So I'll write this operation over here. Okay, I'll write this operation supported. I am teaching you as a language agnostic. Language agnostic means because I am not taking any language into consideration. You can be from Java back, you can be from C, C plus, or Python. Depends on you. But more or less, the concepts will be similar. So concepts there also you can also define an array in Python. You can also define an array in Java, C plus, or howsoever you want to do it. So what are the support operations? The first thing is traversal. So what's the meaning of traversal? So literal meaning is you are going element wise. So you are traversing the whole list. But traversing I mean, so if you have array like this, so you'll first go to this element, then go to this element, go to this element, go to this element, something like this. So if you just scan a list, something like scanning, traversing, that's what the word travel comes from. Travel means like you go to the places. Here you go through the elements. That's the first operation is you should traverse through the elements of the array. The next operation that we are interested in is insertion. Insertion means you'll have to insert the element at a specific location. Let's suppose you want to insert the element over here. Okay, you should have a way to insert the element. Then you should also have deletion of the element if you want to delete element. Okay, after that you can also have concept of searching. If you want to search for element, you can sort the element. So these are all the operations which can be given. So you can search for a particular element, you can sort the whole array. And these are the operations that we have. So these are the things that I want you guys to know about arrays. So what are the applications of these arrays? They're used as a basic data structure to implement other data structures. Like for example, you can implement hash tables, you can implement matrices, you can implement a lot of stuff by using these arrays. Okay, so now if you know the arrays, because arrays now they are stored in continuous memory, they store the homogeneous elements, they support different types of operations, and depending on the language they are implemented differently. In C or C++, you have arrays implemented differently. In Java they are implemented different. In Python they are implemented very differently. Okay, so these are the implemented detail that a programmer has decided, a compiler designer or a language creator had to design. Okay, how do I want to create the arrays, and then, but these are the basic specifications that you should know about the arrays. Now think about this. Now I will have a discussion on few things. We'll have a discussion on complexity of this. So now I am saying you, if let's suppose I have to search for an element. So this is my array. Okay, so if I have to search for an element, let's suppose I have elements 1 5 6 8 9 2 1, something like this, 2 10. Okay, so if I have to search for an element, so for searching, so what do you think, should we traverse the whole array, or is there a possibility we can do searching in less time or something like that? So if you consider that, but without assumptions, like this array is not sorted, this array is as it is, the specification that we saw so far. So how many operations do you think? What is the complexity of the searching you in the array? So what do you say? So Zakir gave an answer of order n. That means the rationale behind that is he said there is no particular order in the array. So you have to compare whatever you are searching with each element of the array, and then you have to see if it matches that. Okay, that's why order of n. You have to see every element, and everybody agrees on this. Let's suppose now if you want to delete a thing. Okay, maybe here we'll have difference of opinions, I guess. So if you have to delete a thing, this is our array, let's suppose, and you have to delete, let's suppose, any element. So what is the amount of time this deletion will take? As searching took order of n, because you have to compare your searching element with each element, so that to compare if it's equal to this. So what about the deletion?
Sir, again, order of n.
Order of n. Any other opinions? Amir, do you think it's order of 1 or something?
No, sir, order of n,
So why
because
is it
we have
order
to
of n?
shift other elements after deleting.
Sure, yes. So if you delete, let's suppose, this element, so if you delete this, now you'll have to shift the elements here. So this is deletion plus shift. So you first delete, then you shift. That's why it will take order of n operations again. Now insertion. So insertion, how much time should it take? Asrar?
Sir, it depends. Like if we have to insert in uh, beginning or at the end.
Okay, if it's in the beginning, like think about the array. It's not linked list. This is an array. This is the index thing. You can directly go to the index.
Sir, order of n.
So Asrar, what do you say?
If we have to insert at the beginning, we have to shift all the elements to the right. So order of n then.
Okay, Zakir, what do you say?
Sir, if array is of fixed length, then we have to create first a new array
Mm-hmm.
because we have to shift because we have to insert the new element and shift the remaining element towards right.
Mm-hmm. Yeah. Now I told you take without assumptions. Think this array is of fixed length, so insertion will be order of one. Why? Because you'll directly go to the element, you'll replace it. If I have to insert it over here, so it doesn't matter whatever there is. There can be something. So always in the memory location there is something which we call as garbage value or something, junk value. So memory never is clean. So you will not expect the memory is clean. You'll expect there is something. So whenever you go on this location, you'll just create the element. You'll just override it. Let's suppose with 12. It's order one operation. So that's what insertion means over here. In the array, insertion does not mean you append an element. So appending and these deletion, they have different meaning in the linked list. So you remove a node there. Okay, you free the memory location in that. But here you do not free the memory location. You just erase the thing. Okay, that. But in the deletion you were quite accurate because we have to shift the elements. Why? Because you have to access the elements again. In here, if you ask me, for example, if you have to insert an element, let's suppose here right now you see it as a 10, you can insert some other thing. But Zakir was right that if you for example have to insert an element over here, now that the array's length does not extend up to that, so you have to double the array. You have to create a that's what we call as dynamic array. In dynamic array, you will first create an array, again double this array, and then copy all the elements over there. So here we are talking about static arrays, but that's also good. Like at least you folks are focusing on those things. So if the array is full, so what will you do? We'll just create a new array, double the size the previous array, then we'll copy all these elements, then we'll insert this array. And it depends. Normally insertion is order one, and even we proved this in amount analysis also. Insertion is order one. How many of you remember this? So we proved that insertion is order one in the dynamic arrays also. You just have to go to the index and just write it there. So even if it is array like this, and you will insert, like, let's say 1 2 3 4 5. Okay, then when you will insert 6, you will double the array, and then you will first have elements over here, and then you will insert 6 over here, something like this. And when we did the amount analysis, you saw that that time again we got the order one. Is it clear? So are there
Yes, sir.
some other things that you... No, you can even access the subset of array. So there is different ways. Like I'm just being programming agnostic. I'm not telling you ways to define arrays, because that you guys choose your language. Even if somebody loves C++, but most of the things will be coding in Python. Okay. So now let's... This is the end of the theoretical side of array. There are more things to learn, but I don't think they'll benefit you in some way. These are all the things that you should know or must know about the arrays.